Yes.
Teacher.
Okay, we're going to start with calculus as if you've done nothing. Okay.
Okay, that's fine.
Right. So the first thing we need to do is find the derivative. Now, let's assume, okay, let's just work out what a derivative is. A derivative, let's assume that I've got a gradient here. I'm just gonna do a system of axes, but just on the positive side. And I've got that's not a curve like that. Let me try and do the curve first. Can you see this curve? Let me make a curve there. Now, if I have two coordinates here, let's make one there and one there, like A here and B here. I can get the gradient by doing y2 minus y1 over x2 minus x1. You remember that?
Yes.
But that's just called an average gradient. That's your average gradient between 2 points. I can also ask you to get a gradient only at point C. Now, if I draw a tangent there, draw a tangent there, it's going to look slightly different. I draw a tangent there. The problem I have, I only have one coordinate. So I can't do like y minus y over x minus x. Do you understand? Can't do that.
Yeah.
Then what I can do, I can use calculus to find the gradient at any point of that curve.
Okay.
Now, calculus is a way to find gradient. So let's assume that graph was fx equals, I'm just going to change something here. Don't like this. Let's say that was plus 1. So it's x squared plus 1. Then I can do the derivative. Now, I'm going to show you how to do derivatives today. That's the first thing. And the derivative is a method to get the gradient. So
Okay.
let's just get a blank page and just play around with derivatives only. Now, I'm going to show you how to do the derivative. I'm going to just give you any equation there. Plus 2x minus 4. So let's assume that's the equation. 3x squared plus 2x minus 4. Now, to get the derivative, you can write y dash, or it's called y prime, or you can just do dy over dx. That's called the derivative of y with respect to x. So both of those two things mean exactly the same.
Okay.
Okay, so you can write either, we use dy over dx a lot. So what you're going to do, you're going to take the exponential value on top of that x and multiply it with a 3 in front. That gives you a 6, isn't it?
Yeah.
And then you can subtract 1 from the exponent. Same you're going to do with the next one. There's invisible 1 there. You're going to multiply that with a 2 in front. Then you get plus 2. And then you're going to subtract 1 from that 1, which actually gives you x to the power of 0. But anything to the power of 0 is just 1. So it's just 2 times 1. So you can just cancel that. Happy?
Yeah.
And the 4 doesn't have an x to it, so you can't do the derivative. Or you can think of it as negative 4x to the power of 0. Minus 4 times 0 is 0. And then I have x to the power of minus 1. But that just stays with 0. Can you see that? So you can just leave it. You don't have to do the derivative if there's no x. So that was fairly easy. Huh.
Yeah.
So this thing, which is really important, this is an equation to get any gradient on the graph y equals 3x squared plus 2x minus 4. If you draw that graph, you can use that equation, 6x plus 2, to get a gradient anywhere. So that graph will look something like this. If I minus b over 2, oh yeah, it would look something like that. There's the graph. And the equation 6x plus 2 can get me a gradient anywhere. Anywhere. Okay.
So is your 6x plus 2 classified as an equation, but it can be used to get any gradient?
It is the derivative, but the derivative gives you an equation to find any gradient. Now look at what some interesting gradient here. Right there at the turning point, the gradient will be 0. Look, if I draw a tangent there, it doesn't have any gradient. You see that?
Yeah.
So I can take the 6x plus 2 and make it equal to 0. So I'm taking the gradient and I'm making the gradient 0. Because the gradient there is 0.
Yeah.
Then 6x equals -2 and x equals -2 over 6 or a third. So that x value there is -a third.
So
So
then when will your gradient be equal to 0?
at the turning point, look, can you see at that turning point, if that dotted line doesn't have a gradient? Only a line that looks like this or looks like that has got a gradient. But that line does not have a gradient. So I can see that the gradient is 0. So if I set the gradient equal to 0, I solve the x at that spot. I can also say, look, maybe there's an x value there of 2 and a y. What is the gradient at that point A? Now you must focus now. Okay, then I say, look, 6x plus 2 is an equation to get any gradient. It's called the derivative, or you can use dy over dx. Therefore, where x is 2, what is the gradient? I can just do this. Therefore, 6 times 2 plus 2 is the gradient. And that is 12 plus 2, that's 14. So at that specific point A, the gradient is 14. It looks right. Look, it's a positive gradient and it's very steep, isn't it?
Yeah. It looks quite steep, yeah.
Yeah, so that's it. That's why we're doing derivatives. So the first thing we're going to do, we're going to play around with this method, and then we're going to do first principles.
Okay.
Okay, so let's play. I've just showed you what we need to do and where we're heading. But now we first need to do a couple of examples. So y equals, let's say, 2/3 x to the power of 3 plus, let's say, x over 5 minus root x plus 4. Okay, the first thing we need to do is get rid of difficult fractions or roots. So I'm going to rewrite that as 2 over 3 x to the power of 3 plus 1 over 5 times x. Is that correct? Yes.
Because x
Over
like what?
5 is the same as 1 over 5 times x over 1, which is the same as a fifth x. No.
Yeah.
Okay, and that root of x is the same as x to the power of half.
Yes, that's
Because x1 root, it's got an invisible 2 there, and then I divide the exponents with one another. And then plus 4. So the derivative is 2 over 3 times 3 is just 2. And then I subtract 1 from the x, I get that. Do you understand that?
yes.
And then 1 times a fifth is a fifth. I'm going to subtract 1 from that x, so it becomes x to the power of 0, so it's gone. And then a half times -1 is negative a half, and then we subtract 1 from that half, I get negative a half. See if you understand what I've just done.
Okay. Just having a look.
You seeing that? Hello.
5 and then negative. Yes, yes. Okay, yeah, I'm with you. Wait, but why is the top one also negative?
What top one?
The top exponent for the n value negative a half x and then
Okay, so I had negative x to the power of a half. So I take that exponent, I multiply it with a negative 1 in front. Then I get negative
Yeah.
half. And then I subtract 1 from a half. A half minus a 1 is minus a half.
Okay.
Okay. Happy with that?
Yeah.
Okay, I'm going to make this small. Let's do another one. You do this one first.
Okay.
Y equals 2 over 5 x to the power of 4 plus x to the power of 3 over 2 minus x over what? Let's make that x squared over 4 plus third root of x. See if you can do that.
Okay.
You are allowed to use a calculator, obviously. You can multiply 2 over 5 with 4 if you don't want to do it in your head.
Okay. This is going to be a long one though.
Yep. Just fix those two fractions first, eh? I should have changed
Okay.
something. Can I still change something? Because it's too monotone. I want to change the x squared over 4 to 4 over x squared, okay? Sorry about that, but that's going to test everything.
So. So how would you approach a sum like this?
Okay,
So
let's
what should
start.
you look for?
Just do the first bit where you get rid of the difficult stuff. So that second term is a half x3, isn't it?
Yes. So because Sir just went put the x next to it and put the one with the x.
Yeah,
Because
if anything is on top, I can just put next to it.
that was what I was going to do with the 4 and then
Yeah, but
Sir
you
put the
can't. That is 4, and then only way to put it up or next to it is when the exponent changes sign.
Oh yes, okay, so we can do that.
And that's x third. Okay, now see if you can do the derivative of that.
Okay. Okay. Sir, I got 48x plus
48x. Whoa, 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 whoa.
Oh, sorry, 48x over 5
8 over 5.
plus 3. But no. Do I say, because my first one was 24 over 5
How do
x
you get
squared.
24 over 5?
Because I took, okay,
No,
so for my first,
2 over 5 times 4 is 8 over 5.
yes, and then I took the 3 and I multiplied it again.
No, you can't do that. You have to subtract 1 from the 4.
So you
Look.
can't keep going
No, you
down.
can't double it up. Look, 4 times the number in front. 4 times 2 over 5. That is 8 over 5. Then I subtract 1 from the 4. Then I get 3. And that's finished then.
Okay. Oh, yes, because you're working with cubes.
Okay, then 3 times a half is 3 over 2. And then I subtract 1 from the x. Got that?
Yeah.
What is the next one? Minus 4 times minus 2 is plus 8. I subtract 1 from the x. What is negative 2 minus 1?
-2 minus, wait, where? Oh, there we go. -1 will give you -1.
Yeah. I owe you 2 grand. I owe you another grand. I owe you 3
Oh,
grand.
that's 3, sorry. I was thinking the
What's
one
wrong
was one.
today?
Ah, it's the weather. We've got miserable weather here.
Okay, and then a third, I multiply with 1 in front. I get 1 over 3. And then I go my calculator and I do that. That's x to the power of minus 2 over 3.
Okay.
Because I know you have to get this right, eh?
Okay, now well,
Okay. So I've showed you this is called product rule.
okay.
Product rule. This is the only one you do in school. There's another 4 or 5 methods we can do calculus with, but you're not doing that in school syllabus. Okay.
Okay.
So this is the derivative. This is if they ask you to do the derivative, this is the only method you're going to use. Okay, product rule. So I'm just going to show you something else quickly. So if you have something like this, fx equals 2x squared minus 3 squared, then you can't do the product rule. The first thing you need to do is multiply that out. 4x4 minus 12x squared plus 9. Okay.
Okay.
And then you can do the derivative. Look, I'm just writing f dash, which means derivative.
But
Instead of y
so
dash. Hmm?
don't we get second derivatives as well?
Yes, we'll get there.
Okay.
Okay, so this is 16x3 minus 24x. Got that?
16, yes, I got
Okay, good. Now this is called product rule. Chain rule. Chain rule looks different. This is not, you're not going to do the chain rule. This looks like this.
that. Okay.
But this is chain rule. Chain rule is additional math. You don't do that. Okay, good. Right, so I'm assuming that you're going to practice a couple of these. Do these
Yeah.
on the VSI lab. There's a little test on derivatives. Okay.
Okay.
Or you can do
Okay.
your homework or stuff in the book. Okay, this is one method. Then the way they got this method was through what is known as first principles. And I think you've done this. The equation looks like this. The derivative of x equals where the limit of x equals 0 of f of x plus h oops, that looks a bit unneat, minus fx over h. Did you see this?
Yes.
Okay, this is exactly the product rule, really. But it's done through, the derivative is done through first principles.
So then Can they in a test or exam say, okay, but you've got to use a specific rule, or can you use
Yes.
either one?
No. They are going to tell you to use first principles. Then you have to use this. Otherwise, you can use whatever you want to. But if they indicate that you have to use first principles, then you have to do this method.
Okay.
Okay. Right, so now they're going to give you fx equals 2x squared minus 3. And they want you to do the derivative of that by using first principles. But you know what? You already know what the answer looks like. It's just 4x, isn't it?
Yes.
So what's really nice, because you can do the product rule, you already know what the answer is. But now you have to go through all of this long method and write the derivative equals the limit where h tends to be 0 of fx plus h minus f of x over h. So some students go in the side or on a different piece of paper and write fx and write f of x plus h out. So fx is easy. That's just 2x squared minus 3. And f of
Yeah.
x plus h is 2 bracket x plus h squared minus 3. Now look at that. Tell me that you understand exactly what that is, or how I got that.
Doesn't the x value become x plus h?
Yeah, exactly what happened. That x value there was just substituted with a bracket x plus h. So some students then multiply this out. I don't do it. I just go back into this equation and say this is the limit where h tends to be 0. What color am I writing now? Does it look green?
It's green, but so was also using purple, like a purpley
Yeah.
color.
Is this a better green than the one above?
Yeah, it's much darker.
Is it nicer on the eye?
Yeah.
Okay, good.
Yeah.
Right. So look at this. This is 2 bracket x plus h squared minus 3. So that's fx plus h. Then minus in brackets fx, which is 2x squared minus 3 over h. Can you see that?
Yeah.
Good. Now, what is really important is that whatever comes out of this section here must cancel. You always get these marks. You always get the summing exam. So this is 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3 over h. So can you see whatever came out of that bracket has cancelled? That last bracket. See that?
Yeah.
Good. And now look at an easy way to finish the sum is just to factorize h on top, so I can cancel it at the bottom. Then I get 4x plus 2h. And now those two h values cancel. And then I make h 0. So there h is going to be 0 also. And then the answer is simply 4x. But that we knew.
Wait, so the h, where did the other, oh, wait,
That
4x
h
is
there,
equal. So do we
we
take
made
away
it
the h?
0.
Oh, yes, because of the
But we're
rule.
not allowed to make a h 0 at the bottom. So we first need to cancel that h at the bottom.
Okay.
We can write this down.
Okay. I've got it.
Let's do another one. F of x equals 3x minus x squared. And I want to know what is the derivative of x by using first principles. and they give you this equation. Okay.
But so since we have no values, would we just use fx?
No. Go to the side quickly, and then you write fx. That is 3x minus x squared. Isn't it correct?
Oh, sorry,
And what is fx plus h? That is 3 bracket x plus h minus bracket x plus h squared. You can multiply that bottom one out if you want to.
Okay. So I have gotten to the point where I got to 3x plus 3h minus x squared plus 2xh plus
Okay.
h squared.
So you have to write equals the limit where h tends to be 0. You can help me now because I can't remember everything you're saying. So this is 3 bracket x plus h minus x plus h squared minus, and then fx in brackets, which is just 3x minus x squared.
Okay.
Okay, and then I'm just going to multiply that brackets or those brackets out. Okay, so I have 3x plus 3h minus, I'm first going to do the multiplication. That's, or you can multiply the minus in afterwards if you want to. That's x squared plus 2xh plus h squared minus 3x plus x squared over h. No.
Yeah.
Okay, so this is the limit where h tends to be 0 of 3x plus 3h minus x squared minus 2xh minus h squared minus 3x plus x squared over h. Now, those two things must cancel. That one must cancel. That one must cancel. See that?
I'm just having a look so that, yeah, those two will cancel, and yeah, those two will cancel.
Okay, awesome. How will I get rid of the h at the bottom?
Well,
What about factorizing a h out of the 3 terms that are left? No,
we can.
that would be really helpful because that will be allow you to cancel the h at the bottom.
Yes, you can, because it's a commonality.
Yeah. So that's what remains, isn't it?
H3 minus 2x. Just having a look at 1, 3. Yes, that will remain.
So if I make that h0, the answer is just 3 minus 2x. But that you knew from the beginning. Look, if you do this derivative, it's 3 minus 2x, isn't it?
Yes.
So that answer is correct.
Oh, you can
Yes.
actually.
Okay, you're on your own with the next one.
Okay.
I'm not going to make it as difficult. The function fx equals x squared plus, no, yeah, plus 5. Do the derivative. What is the derivative by using first principles? On your own.
Right.
So the derivative is the limit where h tends to be 0 of f of x plus h. Your book is going to explain to you what we're doing here. Why is it f from x plus h? H stands for height.
Okay.
Don't worry about that. You don't need to be able to explain that. I can explain it to you, but it's a waste of time. We'll see at the end of the lesson if we have time.
Okay.
We're managing they'll know.
Yeah, the only thing is I've confused myself now, which is actually quite silly because f, I don't know what value to use for f in front of the bracket.
Always
I
do this in the side. Fx equals x squared plus 5, and then fx plus h equals x plus h squared plus 5. Is that correct?
Yes, that is correct.
So
Yeah.
now you fill in those two things and then you multiply everything out. Oh, sorry, I've got a mistake here. Look, there's not a plus there, it's a minus. Sorry about that. I don't know why I got a plus there.
So my 5 remains, and that's what's throwing me off is the 5.
Okay. So let's just fill in the values. That equals the limit where h tends to be 0 of x plus h squared plus 5 minus in brackets x squared plus 5 over h. That is the limit where h tends to be 0. I'm going to multiply that out. I get x squared plus 2xh plus h squared plus 5 minus x squared minus 5.
Are those taken?
Gone. Yeah, you didn't do those brackets, eh?
But how come? Oh, yes, that one. Yeah.
Go fix it. Finish it.
So 2xh plus h squared over h will remain. Then will we take a h out
Yes.
and make it 0?
We're going to factorize h out on top. I get 2x plus h over h. Then these two h's cancel. And the other h I make 0. And then I have 2x left. But that's the answer from the beginning.
Okay. So then, okay. Yes, I give the same answer.
Okay, awesome. I'm gonna quickly copy this and send this. This is homework that I want you to do.
Okay.
See, you didn't have any questions for today, do you?
No.
Those I want you to do using not first principles, but the product rule.
Okay.
And I've got another page here. These I want you to do with first principles.
Okay.
Eerste beginsels is first principles.
And then for when must I do this, sir? For next week Monday or for tomorrow?
No. whenever.
Okay. I'll have a look at them and see if I can't get them done then. I
Yeah,
can maybe
whenever I
have-
see you again. I'm
Okay.
trying to trying to put on the on the link I'm trying to put the subject, what we're gonna do,
Okay.
but I'm not sure yet with the maths. Okay,
Okay.
because you have
Okay.
2 physical science classes that you can attend, the one on Tuesdays and the one on Wednesdays.
Yes.
How good is your
But obviously,
Afrikaans?
my Afrikaans is fine.
There's always a Tuesday evening 7 to 8 maths class where you can ask questions.
Okay. Okay. And then, so I just wanted to ask, how come Cole is no longer in the classes?
He stopped.
Because did he just stop?
Yeah,
Okay.
yeah. Okay, I think
Because
we've done what we have to do today.
are we done?
No, if you have questions, but we can't do anything unless you could do this. Then we can't do the graphs. The next of the work is a lot of work.
Okay.
I want
Okay,
you,
but it's
the other thing is really important, Zelnay, is to finish that assignment.
okay. I'll get it done as soon as possible.
I think the assignment consists of 2 sections. One with calculus. Is this the assignment? Task.
It's possible. It's
Uh,
possible.
Is it called investigation?
Yes, I think so.
So
But
this
I'll go
section
look.
consists, this might be the assignment. I'm not 100% sure, to be honest. But if this is the assignment, we have to, this is math term 2. This is
So
the calculus.
does Sue think once we finish calculus, we could quickly run through the task?
Yes.
Okay. Thank
So
you.
next week we'll start with graphs.
Okay.
Do you have
Okay, then
questions? What have you done this past couple of days?
well, like I've said, I've been looking at mostly at what to do when planning out how I'm going to be studying. But the math I've been looking at was exactly this. But I did not take in the consideration that, you know, where at the end you'd have, let me count, 1, 2, 3, maybe 4, 5 variables. I wouldn't say, okay, take the 1 away, and then I just take the x away. So that's where I've been making my mistake today. So I'll
Okay.
go practice on those and then see if I can't get questions for next week.
Yeah. Just remember there is also a Afrikaans class on Tuesday evenings.
Okay.
And
I think
but you don't get that link.
okay. I actually don't know. I think Sue sent it to me because tomorrow we have
Yeah, I
physics
can
and
always send it to you if you want it. Okay.
thank you, sir.
All right. Keep well.
Keep well.
Bye.
Bye.